CHEM 2212. This is the Fischer esterification. With the Fischer, we're going to be combining a known carboxylic acid, which is our glacial acetic acid. We have 5 milliliters of our glacial acetic acid, with an unknown alcohol. And the unknown alcohol that we've chosen, the code is R63462B. We're going to measure out, let's take a look at our procedure. We're going to measure out 4 milliliters of our unknown alcohol. So let me do that underneath our snorkel real quick. This does have a very strong odor, so we want to make sure that we keep it under our snorkel as we're measuring it out. Turn it just a little bit. And there we are, right at 4. So I'll go ahead and cap this back out. Okay. Our catalyst for this reaction is concentrated sulfuric acid. We're going to add all these components into our microwave vessel. We're going to do our reflux in our FlexiWave across the lab. So let's go ahead and pour in our unknown alcohol. Take our glacial acetic acid. And we'll pour in our sulfuric acid. We have just 1 milliliter of our concentrated sulfuric acid. This is a catalyzed reaction. Okay. I'm going to place inside my vessel our stirring bar. And we'll go ahead and seal the top. Place my thermal well in. Put it inside the safety shield. And we'll take it over to the FlexiWave instrument and get everything set up. So we have all of our reagents placed inside of our Teflon vessel here. The Teflon vessel is placed inside of our safety shield, so let's go ahead and get it set up inside the microwave unit. We have our temperature probe. We're going to place that through the center of our safety shield cap. This probe is very delicate, so we have to be very careful when we do this. Okay, there we have it. We'll place our vessel in position number 1. I'm going to add my Teflon wafer to the top. There's a hole in the top of that, so I'm going to go ahead and put my probe through the center and down into the thermal well. And then very gently close our safety shield. Okay, we make sure that our vent is pointed to the outside. I'm going to seat my probe down into the cap so it doesn't pull out. And we're all set. We'll put our brace in. This again is just to hold up our vessel so it doesn't tip over during the course of our reflux. Once we have that set in place, we'll close the oven, come over to our control panel. We've got it set to Fischer esterification. All the parameters are set. We'll hit go. This will reflux for 10 minutes. We'll come back and check on it then. So this is a shot from inside the microwave unit. You can see the vessel as it rotates through the inside of the microwave oven. We'll check back in about 10 minutes. reflux is finished, so we're going to go ahead and open up our microwave. We'll take out our brace first. Just do the reverse of everything that we did to put the vessel in, really. Go ahead and take our probe out, being very careful not to bend or break it. And we'll lift it out of the carousel. The vessel is still a little bit warm down on the bottom. I can feel that through the safety shield. So we're going to take it over here to our hood. We're going to open it and vent it into the hood just in case there's any pressure buildup. We're going to have our vent hole pointed inside. There we go. That was our Teflon wafer. We'll take out our reaction vessel. I think we can see our liquid down on the bottom. Is that showing up?
Yeah, it does.
All right. So we're going to take this back over to our station, set up our SEP funnel, and go through our wash. We're back at our lab station. We have our inner Teflon sleeve with our reaction mixture in it. We're going to set up our separatory funnel. We've already got it in our ring clamp. I'm going to place a short stem funnel in the top. We're going to use this to pour in our liquid and to also catch our stir bar that we have inside of our vessel here. I'll go ahead and open this up. The thermal well has a little bit of liquid in it since it extends down below the level of the liquid, so I'm just going to tap that off and set it on our pad here. Then I'll carefully pour our reaction mixture into our separatory funnel. And as you can see, what started out as a clear, colorless liquid is now dark purplish brown. All right, so we have our stir bar captured in our short stem funnel. The next step here is, what's different with our Fischer esterification is that our product is going to form its own layer in our separatory funnel, which means that we're not going to be performing an extraction, which is what we're used to performing in our separatory funnel. We're actually just going to go through a series of washes to clean up the ester layer of our product. We're going to do this, first off, with 2 10 ml portions of deionized water. So I'm going to pour in my first, actually, just to make sure that I've gotten everything out of my vessel, I'm going to pour my water into my microwave vessel. I'm going to swirl it around and then pour it through my funnel. Take the funnel out, set it aside, and let's take a look. It's fairly difficult to see right now the layer separation, but I'll put the stopper on and give it a gentle shake and mix our contents. I wanted to move my snorkel into place so that when I vented this, I'm not doing so into the open air. We'll do this 3 times. There we go. Place this back into our ring clamp. We're going to let this settle for a moment so our layers can form. We'll come back and drain off our aqueous layer. We've let our SEP funnel rest for a couple of minutes and we can see the clear formation of 2 layers. We've got a dark purple top layer and then a light pink or purplish bottom layer. Our top layer is our ester, the bottom layer is the aqueous components, both the water that we added and some of the aqueous components of our original reaction mixture. So let's go ahead and drain out the bottom layer. Remember, this is a wash, so the idea behind this is that we're trying to get any impurities that are water soluble out of our ester layer and into our aqueous layer where we can discard it. Okay, so there's our top layer preserved. Go ahead and set our aqueous layer here. We've labeled this so we don't lose track of it. We've got a second 10 ml portion of deionized water that we'll pour in. And we can clearly see, right, our clear water layer on the bottom and then our dark ester layer on the top. Looking at this layer now that we've removed this first aqueous component, you can actually see a little bit of a yellow tinge to our ester layer. So I'm going to go ahead and put the stopper back in. We'll shake our separatory funnel. Do the vent, second shake, and a third. Now we're seeing a dramatic difference in our color. What originally looked like a dark purple layer is turning out to be sort of a milky yellow. We'll let this sit for a few minutes like we did the first wash, let the layers separate out, and drain off the aqueous layer. We've given the sep funnel a couple of minutes to fully separate, and we can see that we've got our upper and bottom layers nicely resolved. So we'll go ahead and drain out the lower aqueous layer again into our catch flask here. Now we do have some yellow particulate, a little bit of an emulsion that's formed. So we'll drain off as much of this lower layer as we can. And retain our upper layer. I'll give it a swirl just to try and separate some of these. Okay, so I think we've got the majority of our aqueous layer out. Now we'll move on to our sodium bicarbonate washes. We're going to be doing a number of bicarbonate washes. After each one, we'll test the pH of our aqueous layer. Once we reach basicity, once we have neutralized the acid in the system, then we'll stop, move on to our drying phase. So now we have our first 10 ml portion of sodium bicarb. This is a 5% sodium bicarbonate solution. We'll go ahead and pour that into the top of our separatory funnel. Put our stopper back in. And we'll give it a shake and a burn. There is going to be some CO2 evolution as a result of this wash. Because remember, we were highly acidic in the beginning, and this is going to be a mild base workup. So we'll watch as our layers start to separate. We can see our yellowish orange layer starting to concentrate in the top, and then we have a slightly frosted or opaque white layer in the bottom, which is our aqueous. There's also a large number of bubbles here, which is an emulsion or a mix right at the interface between the two layers. So the majority of those bubbles have now resolved. We've got a nice clear separation of our layers. So we're going to drain off our lower aqueous layer. Okay, leaving our ester layer in the separatory funnel. Now I'm going to take this aqueous wash and use some pH paper to test to see if it's basic or not. Now what we're looking for, weakly alkaline is our light green to our bluish green, dark bluish green for our pH of 10 or strongly alkaline. So we're just looking for a basic wash layer. So I'm using my glass stirring rod. I'm just going to dip it in and then touch it to our pH paper. Okay, so we've got a weakly alkaline solution here. We're going to do one more extraction with our sodium bicarb just to make sure that we've gotten all of our acid out. So I'll set this aqueous layer here, but this is looking good so far. There's our second sodium bicarb portion. Put our stopper on. And give it a shake. We'll let our layers resolve just as we did before. And that's happening very similar to what we saw previously. We've got our white, slightly opaque layer on the bottom and our yellowish orange layer on the top. So our layers have resolved. I'll go ahead and put in my beaker once again and drain off the bottom layer. And there we go. So we have just our ester layer remaining in our subfunnel. Next step will be a brine wash to help dry this ester, and then we'll dry it completely with our sodium sulfate before characterization. So now we're moving on to the drying phase. We've got one last liquid wash, which is our brine, a saturated sodium chloride solution. This is actually a drying wash. It's going to help extract or pull any remaining water out of our ester layer. So we're going to use 5 mils of our brine. So we'll go ahead and pour that into our subfunnel. You see our layer separation there. We're going to give it a good shake and vent. Take our stopper out, set it aside, and wait for those layers to resolve. And you're doing so fairly quickly. We just do this single wash. I'll go ahead and put my aqueous catch flask underneath. Once those final bubbles are resolved, there we go. We'll go ahead and drain off our brine layer. So the brine has been removed. The next drying step is to drain off our ester layer. We're going to do this into another 100 ml beaker. So we have our final product here in this 100 ml beaker. And we're going to dry it using a little bit of sodium sulfate. We've done this before. We'll use just a little bit, just the end of a spatula. We'll swirl this around in the solution. And we know that if our sodium sulfate aggregates with water, it will clump up and it will stick to the sides of the beaker. And what we're seeing is that the majority of this sodium sulfate is flowing freely in our ester liquid. Okay, so we have dried up. I don't see any evidence of water really at all. So we've dried up any remaining moisture and we're ready to decant. Now we've pre-weighed another 100 ml beaker. And that's right here. But I've noticed that we've got a small spot of water inside of it, so I'm going to go grab another beaker. When we come back, we'll do our decantation. So here's our 100 ml pre-weighed beaker. Go ahead and set this down. We're going to decant our ester liquid into our pre-weighed beaker. Remember that decanting is pouring of our liquid. It's a liquid solid mixture. We're pouring off the liquid while leaving the solid in the original beaker. So we just have to be very careful and patient with this to make sure that we don't accidentally pour over any of our sodium sulfate. Okay. So there we have it. That is our purified ester product. I'm going to do a quick wafting test. And I get a strong, fruity smell. I'm going to let you use your characterization data once you determine the identity of the original alcohol for you to determine which fruit I'm smelling right now. So make sure you include that in your report. Before we head over to our instrumentation to do our characterization, we need to weigh our beaker to find out just how much of our ester we actually produced as a result of this experiment. And we also want to draw your attention to the fact that there is some orangish yellow ester layer still remaining in our original flask. The idea is that if we tried to pour off every single tiny bit of our ester, it raises the likelihood that we're going to accidentally pour some of that sodium sulfate into our final beaker. We want to avoid that at all costs, but make sure that you include this in your write-up as a possible source of experimental error. So let's go over to our balance. We're going to make sure that we've tiered our balance. Go ahead and place that on our tray, and we see 68 grams. So I'm going to write down weight of beaker plus product is 68 grams, 0.284. Okay. We'll do a quick recap of our data once we get finished with our characterization. But for right now, let's find out how much of our ester we've actually created here. So we've got 68.284 minus 64.942. That gives us a total of 3.342 grams is our total weight for our final ester product. All right, let's head over to our instruments. So we're here at the IR. We've already taken our background spectra, so we're going to come in and put 1 drop of our ester on our diamond cell. We'll come over here. We've already clicked sample collection. We'll hit OK, and let's take a look at what we've got. Okay, so we get a very clean spectra here, or spectrum, I should say. Let's call it CHEM 2212 Fischer Esterification. Oops. Very good. We're going to do our fine peaks so we can get a sense of what's happening up here in the 3000 region. Replace that. We'll go ahead and post this up to ELC so that you can go through and identify all of the important peaks that you see in this IR. Let's head over to the NMR unit now. So here we are at the Proton NMR, our picospin instrument. We've got our Eppendorf tube. I'm going to go ahead and fill that part of the way with our ester. It's the nice thing about this being a liquid product that we don't have to dissolve it with any of our deuterated chloroform or anything like that. So we have our ester layer. We're going to add in our TMS, our tetramethylsilane. That's going to give us our reference signal on our spectrum. There we go. Don't have to put much in for our TMS. We'll go ahead and get that capped. Close our Eppendorf tube. Give it a shake. Make sure everything's mixed very well. And there we go. So we've got an orangish yellow liquid here. First things first, I'm going to have to push the DI water that's currently in the loop out. So I'm going to open my inlet here, draw in some air, carefully insert the needle, close down my inlet, and expel the water out of the loop. Then I'll take a fresh needle and a fresh syringe, draw up our product that we want to test. We can see that we've got some air bubbles, as we normally do. I'll take a chem wipe, put that over the needle, and gently press that air up and out. And we're ready to inject. Open my inlet, gently insert our needle, and we're going to push 10 drops through our capillary loop. Seem to have a little clog, so we're going to clear that and come back for our inject. So we've cleared our blockage out of the capillary. This is a very tiny loop. It's easy for even small pieces of solid to block it. We've cleared it out. We're ready to go ahead and inject our sample. We're looking for 10 drops of our solution to come out the other side so that we know that we've filled the loop. And we're not seeing it as a drop simply because the hose is touching the side of our beaker. There we go. And that's a lot more than 10, and that's okay. We're just making sure that our loop that passes through the center of our neodymium magnet is filled with our ester sample. We'll come over here. We're set for 8 scans. We've titled it CHEM 2212 Fischer Esterification. Let's go ahead and start taking our readings. Okay. Of course, the first scan is always a little bit rougher. It's going to refine itself over time, so we'll just be patient and wait for all 8 scans to finish. Looks like we resolved some of our phasing issues down at the bottom. %50 complete. All right, we're at 100. We still see some phasing issues here that showed up right at the end. Let's go ahead and zoom in so we can see our general spectrum here. We're going to put this through MNOVA, go through and set our TMS to 0. That will give us the appropriate delta values, the shift values for the rest of our peaks, so that you'll be able to determine the exact identity of your starting alcohol. So we'll do a final recap of our data sheet now that we're finished with the experiment. We have our initial weight, or really we were looking at our initial volume of our glacial acetic acid, which was 5 milliliters. Our unknown code, that's the code of the alcohol that you have to determine the structure for, so R63462B. The initial volume of that alcohol was 4 milliliters. Concentrated sulfuric acid, we used 1 milliliter. We did 2 deionized water washes, right, at 20 mils, total of 10 and 10. We did 2 10 mil washes with our 5% sodium bicarbonate solution. And then we used roughly 1 gram of our sodium sulfate to dry our ester layer at the end before we went through and did our IR and NMR characterizations. The final weight of our product that we recovered was 3.342 grams. I've made some observations here at the bottom. So our initial reaction mixture was clear, transparent liquid. After we refluxed, it turned dark purple/brown, and it was an opaque liquid. Our ester takes on a yellow hue after our first wash with DI water. And we see that it ends up being a dark orangish yellow color as a result. In the end, we had a yellow to orange transparent liquid as our ester, our final ester product. Then we have the weight of our beaker and, of course, the weight of our beaker plus our product. So that's everything we've got on our data sheet. Good luck with your lab reports.